We have to find the moment of inertia of a circular ring. First, we recap our formulas. One is the formula for moment of inertia, which is given by m into r square, where m is the mass of the particle and r is the distance of the mass particle from the axis of rotation. Second is parallel axis theorem, which gives that moment of inertia about an axis parallel to the axis through center of mass will be equal to moment of inertia about the axis through center of mass plus mass of the body and a square of the distance between the two parallel axes. Third one is perpendicular axis theorem, which is given by Iz equal to Ix plus Iy, where x, y, and z are mutually perpendicular axes. So to find the moment of inertia of circular ring, which is a continuous mass distribution, we use integral and differential method. Here, mass of the circular ring is suppose m and radius is capital R. Because it is a continuous mass distribution, so we will take an elementary length of the ring, say this is dx, and we will find the moment of inertia of this elementary mass and then integrate to find the total moment of inertia about the axis, which is perpendicular to the plane of the ring and passing through the center, and this axis is suppose z axis. Therefore, we can write that m is the mass of ring, r is the radius of ring. So length of the ring will be equal to circumference, that is 2 pi r, and linear mass density will be equal to total mass divided by total length. This is linear mass density. Now, to find the elementary moment of inertia due to the elementary length dx, we will have that this is dm, mass of this elementary length, into distance of this elementary length from the axis of rotation is again r, so it is r square. So we can write it is lambda, this is the linear mass density, length into r square, and lambda can be replaced by m by capital L into dx into r square. So to find the total moment of inertia about the z axis, which is perpendicular to the plane and passing through the center, it will be integral of di over whole closed loop. So it will be equal to m by L into dx into r square. This will be equal to m is constant. This L is circumference, that is 2 pi r. So we can write it as 2 pi r into r square. These are constant terms, so taken out of the integral, and remaining is dx over the whole closed loop. And this will be again circumference. This is 2 pi r. So it will be equal to mr square by 2 pi r into 2 pi r. This 2 pi r get cancelled, so I will be equal to mr square. Therefore, moment of inertia about z axis, which is passing through center of the ring and perpendicular to the plane of the ring, will be equal to mr square. Using this formula, we can calculate the moment of inertia of the circular ring in different cases. For example, in case 1, we have to find the moment of inertia of the ring about its diameter, which is in the plane of the ring. If we draw the figure, this is the ring and a diameter is passing through the center along the x-axis. Another diameter is along the y-axis. And distribution of mass about the x and y-axis are equal. We can use perpendicular axis theorem, which says Iz is equal to Ix plus Iy, and Ix equal to Iy equal to pi diameter. So we can write that Iz is equal to 2 into moment of inertia about the diameter, or moment of inertia about diameter, which is in the plane of the ring, will be equal to Iz by 2. And Iz we have calculated mr square, so it will be half mr square. Similarly, in another case, if we have to find the moment of inertia about the tangent, which is in the plane of the ring, and situation is like as shown in the figure, this is the center and it is the tangent. We have to find the moment of inertia about the tangent t dash. So we will use here the parallel axis theorem. We already find that moment of inertia about the diameter, this is I diameter, it is equal to half mr square Therefore, we can use parallel axis theorem, which says that ITT dash will be equal to I diameter, mass of the ring, this is m, and distance between these two parallel axes, and this distance is radius of the ring. So it is mr square, and it will be equal to half mr square plus mr square, and it will be equal to 3 by 2 mr square.